Okay, welcome back. This is part 6, and I thought we'd look here at our student e-text. This is module 7, section 9 on the inverse trig function. The first 5 videos I was showing you the restrictions of sine and tangent and cosine. When we restrict their domain so that they're one-to-one, we can talk about their inverses. So I want to point out this traditional word for inverse sine. Right here at the middle of your screen, I'm circling the word arcsine. That's another name for inverse sine. So that's a traditional name we can use. And let's see if we pull down the text a little bit. Let's see if they use the inverse symbol of the superscript -1. I'm going to scroll back here in just a minute. It looks like they're using arcsine, and I'll show you here in a minute the symbols that your graphing calculator will use. Okay, so now while we're on this page, you can connect page 85, this idea of restricting the domain of sine to the interval negative pi over 2 to negative pi over 2 to positive pi over 2 inclusive. And that's what I showed you on that last video for sine. And here your publisher has swapped the roles. Now the input axis is the value of y, and the vertical axis, the output axis, is angle measure. And they have graphed the inverse sine. An inverse sine applied to y will give us the measure of an angle theta. Okay, and you'll see that now the domain of arcsine is -1 to 1, and that's represented down here. This used to be the output values for sine. And then if you look along the vertical, the maximum output of arcsine is pi over 2. The minimum is negative pi over 2. And that used to be the domain of sine, but now they're the output values for arcsine. Okay, so at the bottom of this page, I believe we're on page 85. There it is. There's we've got the definition for arcsine, the domain of arcsine, which used to be the domain. The domain of arcsine was the range of sine, and then the range of arcsine are these angle measures. And this is the traditional way of writing arcsine. Your calculator will use this way and put a superscript -1 attached to the n in the word sine, not to be confused with reciprocal function, and they're warning you of that here. Okay. You do want to read ahead. We should have already read this already, but I want to really prompt you to do that now. So example 28 will give you an example of evaluating arcsine. And then there's this example B. That's kind of neat. Sine is restricted to angle measures in the first and the fourth quadrants. So if we're looking at an angle measure of -0.3, that's a clockwise rotation of 0.3 radians. And if we measure the vertical distance to the horizontal axis, we see that that sine value is -0.3 for this point P. And arcsine will take you back to see how many radians. And I hope I said that right. I think I may have misstated. So again, arcsine of -0.3, that should mean this vertical distance to the horizontal axis to point P is this -0.3. And arcsine will take you backwards and give you radians. So I think I misspoke the first time. Read that carefully, because that's easy to miscommunicate. Okay, now I don't want this video to go too long, but as I scroll through, you see the publisher is going to talk about other quadrants, like the quadrant 2 and quadrant 3 on the unit circle, which would correspond to this interval pi over 2 to 3 pi over 2. And so she'll talk more about the natural domain of sine and how to find solutions to equations that lie on that interval. Okay, so I wanted to prompt everybody to be looking through this wonderful book, how they have these lovely illustrations that I can't even come close to drawing. I see in example 29, the publisher has labeled these quadrants. Anytime we see a circle, that's an illustration of how the quantities theta, x, and y are related. And then as we continue on, we might get rotation and context. And I'm trying to scroll until we get to a graph again. Okay, and just to finish up this video here on page 94, I wanted to show we continue to have these illustrations with circles, but we need to start making the connection to this abstraction of the graph, where we take two of those many quantities, and one of those quantities is then its measures are laid upon the horizontal axis, like theta, and here for cosine the output is that x value, the horizontal distance to the vertical axis for point P, where the terminal side intersects the circle. Okay, we'll talk more, but I'm going to let you go for this part, and I'll catch you in video 7.